It's on some free response questions for the applications of the derivative. For these questions, remember how AP style works. You're going to be given a prompt to start out a series of questions, and all of the questions then are related to that prompt. So we'll be using the position of a particle with the function e to the t minus 2t f of t. And question one is asking us for the average velocity. So remember, average velocity is the slope the algebra way. So you're going to be using y2 minus y1 over x2 minus x1. Now, this problem you can use your calculator on. So I'm going to switch our mode over to Desmos so you can see that I'm going to actually put in the position equation. Now, Desmos doesn't understand having t as the variable. So I'm going to just do this because it's the position. I'm going to say that the f of x is e to the x minus 2x. Okay. And one thing I love about Desmos is you can just ask it for the values you need. So I just ask it for the position at 3, that was 4.086. The position at 1, 0.718, and I'm dividing by 2. Now, you can then use a, whatever calculator. If you want to use Desmos, it definitely will do the subtraction here and dividing, and I get 6.684. Now watch my units here because my position was given in feet and my time interval was given in seconds. So this is feet per second. Look at your position was on top, so that's feet, and your time was on the bottom, that's seconds. Now, question B then asks us in what direction is the particle moving and what is the velocity at 2? So I'm going to cancel out these values here and I'm going to ask it for the derivative at 2. What I love about Desmos is I can just put the prime notation. Now, when you write your answer, though, for AP style, you'll need to go back to being the velocity. So the velocity at 2 is the derivative at 2, and that is 5.389. And that also is in feet per second. Okay, now don't forget to answer the question about the direction because this is positive. The object is moving or the particle is moving right. Because the velocity at 2 is positive. Okay, don't have to write a book for AP, but you do need to justify the answer, especially if they said justify your answer. That means points are being assigned to that. Okay. C says, what is the acceleration of the particle when the velocity is 0? Okay, so first thing we've got to do is find when the velocity equals 0. Now, I understand using the calculator, and I want you to. The first thing, though, that I need to do is not set it equal to 0. The first thing I need to do is to find the velocity. I have to show this because it said the direction, show the analysis. Okay, so I actually have to show that I took the derivative, I set it equal to 0. Now, at this point, if you want to go to your calculator to get the value, you definitely can do that. I would take this one off and I would just say, I want you to plot f prime of x. That's the red one. And you can see that Desmos will tell you that value when it equals 0. At that point, you can just write the value. But because the problem said to show your analysis, you actually have to show the derivative and set it equal to 0. Okay, now it wants to know what is the acceleration at this value. So we know that the acceleration is the derivative of the velocity. And so we have that the acceleration is just e to the t. Oops. And again, I'm showing this because it asked me to show my analysis. Okay. And so then you can just put in f double prime of 0.693 and you get a nice value that rounds to 2. Now, why didn't I get exactly 2 from my friends who actually found t to be the ln of 2? The reason I didn't is because 0.693 was rounded. Therefore, I wasn't going to get exactly 2. All right. D, is the speed increasing or decreasing at 1.5? So remember that in order to be speed to be increasing, acceleration and velocity have to have the same sign. Otherwise, it's decreasing. So what we need is the velocity at 1.5 and the acceleration at 1.5. So again, I'm going to my calculator. I'm going to delete these two, and I'm just going to ask it for the velocity at 1.5 and the acceleration at 1.5. Okay, so my velocity at 1.5 is 2.482. My acceleration is 4.482. So because they have the same sign, the speed is increasing because velocity at 1.5 and acceleration at 1.5 have the same sign. Or you could say they both are positive. That would work as well. Okay, remember with AP, stay away from using the word it. Okay, it is very vague and it leaves doubt as to did you really know which one you were looking at? And so you have to be real careful. Okay, second free response that we'll look at in this video, and I'm going to switch back our view so you can see my chart a little bit better. There we go. Love the chart questions. Is there a value on -2 to 1 where f is equal to 0? So you have two values or two theorems that guarantee you a value for the function, extreme value theorem and intermediate value theorem. This one is playing on intermediate value theorem. So let's find out on -2 to 1, is there a place, can there be guaranteed a value where the function equals 0? So I've got some positives, I've got negatives. So this is a yes. There is a value f of r that equals 0 on the interval -2 to 1 by intermediate value theorem. Oof, I wanted to write Roman numeral. I wanted to do IV by the intermediate value theorem. And that's because um, f of 1 is 0 is between f of 1 and f of -2. Okay, now B says to approximate the second derivative of 1.5. So second derivative, we need the slope of the first derivative. So to get the second derivative of 0.5, I'm going to do the slope between, on the derivative, I'm going to do the slope of the derivative between 1 and 0. So you're going to get your values from the chart. G prime of 1 is -5. G prime of 0 is -2. And so I get -3 there. So what does that say about the graph of the function? Well, if the second derivative is negative, G is concave down at x equals 0.5 because G double prime of 0.5 is negative. Okay, now let's look at C. We're told the H is now defined this way. We want the equation of the tangent line. So in order to do a tangent line, you need a derivative and a point. So let's do the point first. We want h of -1, which is f of -1 squared plus g of -1. So f of -1, coming back to our chart, f of -1 is 2. And g of -1 is 2 also. So 2 squared plus 2 is 6. So I have the point -1, 6. Now I need the derivative. So we'll do chain rule. That'll give me 2f of x times f prime of x. And then the derivative of would be g prime of x. And again, we need these at -1. So I've got to go find all of these values at -1 in my chart. So f of -1 is 2. F prime of -1 is -2. And g prime of -1 is 1. So 2 times 2 is 4 times -2 is -8 plus 1 equals -7. That's my slope. So now I can write my equation of my line. Y minus 6 equals -7x plus 1. For my slope-intercept people that you just want to get it into that nice form, you would get y equals -7x minus 1. Okay, we've got one more problem here, part D, and I'm going to put it like this so we can still see our chart. So now it's saying, is there guaranteed to exist a value C such that H prime of C equals 0? So now we're going to the theorems that guarantee us a value for the derivative, and that is Rolle's theorem and mean value theorem. Now, Rolle's theorem is that we're continuous and we're differentiable. We were told that originally in the prompt. And so now the third condition of Rolle's theorem is that the endpoints are equal. So what I'm looking for is there a place on h of x? Now remember, h of x is still defined as f of x squared plus g of x. Is there a place where these two, I could get two different values of x, and I would end up with the same endpoint? Okay, so I need to try those and see what works for us. So let's try -1. Actually, let's try -2 first. And let me pull it down here so you can see those values in the chart, because I want you to have those. Okay, so if I do h of -1, I've got to go find these values. So f of -1 would, sorry, I was going to do it at -2. Let's do -2. F of -2 is 5. So square that gives me 25. And then g of -2 is 4. That gives me 29. Okay, all I'm needing is two that are the same y value. Let's do h of -1. F of -1 is 2. 2 squared is 4. G of -1 is 2, so I get 6. Okay, h of 0. F of 0 is -1. Square it gives me 1. G of 0 is 3, so I get 4. And then let's do h of 1. So f of 1 is -3. Square it gives me 9. And g of 1 is -3, and that gives me 6. So yes, we've found two that are the same. So yes, there is a value C such that h prime of C equals 0 on -1 to 1. And I didn't need to check -2, did I? Okay. Because Rolle's theorem, I'm just going to say guarantees it when h of -1 equals h of 1 and h is continuous and differentiable. So I hope that helps with the free response. I love the approach, getting to use all the resources we have to put this together. And I hope you're seeing the connections that are being made with the free response. As always, if you have questions or comments and you'd like to leave them below, I'd love the opportunity to clarify in any way that I can. Don't forget to hit that like and subscribe button. That way you get a notification every time a new video is posted. Bye for now.